Assalamualaikum and hi everyone. Today we are from group 18. We'll explain to you guys about the amplitude phase shift keying. In here are our group members: Nurul Najwa Najiha binti Zarul Nizam, Nurul Diana Fadilah binti Jamaluddin, and Nurul Shazlin binti Muhammad Zamri.
Theory for amplitude phase shift keying (APSK). Amplitude phase shift keying (APSK) is the emerging modulation scheme used in deep satellite communications and known to have a high spectral and energy efficiency among other two-dimensional memory scheme. Besides, it provides a robust transmission in non-linear wireless channel, and therefore it has been adopted and employed in the state-of-the-art digital video broadcasting standard DVB.S2/S2X. However, APSK is still away from utilizing all available space dimensions, such as its other counterparts, where this potential gap provides the motivation to develop spectrally a more efficient modulation scheme. In this respect, a novel digital modulation scheme called Quadrat Carrier (APSK) (QC-APSK) was proposed. QC-APSK uses two orthogonal carriers to convey ordinary APSK modulated signals to increase the spectral efficiency via doubling the transmission rate. It can be regarded as two orthogonal two-dimensional constellations which occupy four-dimensional signal space. The application of amplitude phase shift keying (APSK). This is one of the applications, so this is the block diagram of amplitude phase shift keying (APSK) modulator.
Okay, hi. Here I will explain about APSK modulation coding. So here you can see we set the value of vector of constellation for modulation and assume as M. And then we set the PSK ring ready as ready. In this case, we set 3 values for each parameter. You need to know that the sum of M needs to be positive integer power of 2, meaning that the square root of the sum should be positive integer, not a decimal. Next, we will put sum M as the input value of X using suitable command. Then we will use the command APSK mode to apply APSK modulation to the data. Lastly, we use command scatter plot to get output resulting constellation. So this is the data for constellation point are generated. Next, we will try to apply base key modulation with phase offset. So here is our coding. As you can see here, the coding is almost same with the previous one, but this coding we will use only 2 values for M, and we use a new command such as phoff to set the offset values. The sum of M also need to be positive integer power of 2, and the value of phase offset must be less than corresponding element of 2 times pi over M. So for this coding, we need to set the phase offset value as pi over 6. Then we use the same command, it's same from previous coding to plot the output. Then we apply APSK modulation modifier symbol ordering, where the plot will be gray mapping and it will be bit data for each point. The coding until when the input is put in the variable X is the same as the previous APSK modulation. We will use the command de2bi to generate a bit data and to set the MSB at the left side. And then we use command APSK mode constellation and set the input type as bit plot output. And then we doing Apsk custom mapping. So firstly, we create a custom symbol mapping vector here. This custom mapping happen to be another gray mapping. And then we apply Apsk mode with a custom symbol mapping. Then we plot constellation. Bit input is used to highlight that the custom mapping define different gray symbol mapping.
Apsk modulation to input bits. As you can see here, on the right side is the coding for Apsk modulation to input bits. At the first line, m equals to 8, 12, 20, and 24 is the number of circle in each state. For the second line, it shows the radius of each circle and each state for the main point. For the third line, it shows the bits per symbol being calculated using the equation, while m can be obtained from the summation of all circle equals to 64 bits. Next, on the fourth line, it shows the equation to obtain x-axis value. The fifth line was applying a basket modulation using data and new values output. At the second last line was explained about passing through a channel with 25 dp signal noise ratio. The last line was explained about plotting the received constellation using a scatter plot.
For demodulation of 16 bits, first you need to demodulate a system of Apsk signal that has an unequal number of constellation points on each second. After plot the received constellation, you need to define vectors for modulation order and Apsk ring radii. Apply Apsk modulation to the data, then pass the modulated signal through a noisy channel. Then, plot the transmitted reference signal points and the noisy elusive signal points. As we can see in this figure, the constellation warping, which is due to the gain compression of the amplifier, operated near saturation. The points on the inner ring with lower energy are more amplified than the points on the outer ring which have a higher energy. As a result, the constellation collapsed towards the outer ring, and this is due to the AMPN characteristic. Each point is spread in clubs centered around the effective warp constellation. We refer to this effect as clustering, and it is equivalent to have ISI in the resistiveness. For 32 bits demodulation, the vectors and radii is first set at certain values, then we use Apsk mode to modulate the input. Generate the points in the reference constellation by using the command of com constellation. Then we will modulate the data by using the Apsk mode. We will let the signal pass through a channel with noise by using the command awgn. Then we use constant diagram Apsk to plot the constellations. Then the Apsk demode will be used to demodulate the data and compute soft bits. Lastly, here is a demodulation of 64 bits. So the first line shows the number in each state, where the first state is 8, second state is 12, and followed by 16 and 28. M can be obtained by adding all the X marks in each state. The next line shows that for each state distance from the main point, where 0.5 refers to the distance between the innermost state and the main point, and 1 refers to the second state and follows by the next step. And the next line refers to the x-axis, where you can deploy your data. The fifth line creates a custom symbol mapping vector. Sixth line is the modulate data in plot constellation, and the next line is the demodulation of a received signal. Lastly, the eighth line is to verify the demodulated signal and equals to original data. That's all from us. Thank you for your attention.